All right, physical science students, we are going to get started in our physics portion of physical science, which is my favorite portion. And the first thing we're going to talk about is speed. All right, so motion means to move. So it's kind of a simple concept, but we're just going to break it down into what it really means. So, how do we know if something moved? So, if a car goes from point A to point B in 10 seconds, how do I know it moved? Well, the answer is it changes positions. So when you're changing position, that counts as movement. So the example of a horse galloping from point A to point B, it's changing positions. An object changes positions if its background changes. And the background is called a reference frame. So you can kind of feel this when you're in the car. It doesn't feel like you're moving, but the background around you is moving. And that's how you know you're changing positions. All right. So let's do a real life application. So if you don't recognize this person, that's totally fine. But we are going to watch a short YouTube video about him. This is Usain Bolt, and he is one of the greatest sprinters of all time. Like he's insane. And let's see what that means. All right, we will pause there, but there's tons of videos on YouTube if you're interested. All right. So we can say a few things about him. We can say that he changed positions from the start to the end. We know a couple things about his position change as well. We know that he moved a certain amount of distance, and we know that he had a certain time that he moved that distance. So keep that in mind. All right, speed. Some objects move faster than others. So speed describes how fast an object moves. This should all just be like basic common knowledge. And we're only going over it to get us ready for the things that are to come and that we're all on the same page. So speed of an object can be compared to speed of another object, right? That's what the video with the track runners was doing. It was comparing, there was a race and they were comparing each other's speed. In this example, just an eagle flies faster than a turtle moves. So, how do we determine speed? There's two things that we really need to focus on when we're looking at speed, and one of them is distance, specifically displacement. So, how far are you from the starting point? And the other one is time. So, to find speed, we have to have these two quantities, these two numbers. We have to have the distance the object traveled and the time it traveled. Oh, that T is supposed to be under that, but you get the idea. So the speed formula is distance divided by time. So the SI units, we're going to use meters per second, but those are just like the basic units. We can also do kilometers per hour. You may recognize it more as miles per hour because that's what we use, which is not the metric system, but this may be something that you can use as a reference point. All right. So we are looking at our time. You can see that let's start over. We're looking at time, and you can see with each slide I click, it increases in increments of 5. And we are also moving a certain distance. All right. So if a car covers or goes 35 meters, what is the average speed of the car? Well, we know the distance, and here's our time. So we are able to figure out that, and you just need to take 35 divided by 15. All right, when do we use speed? Well, there's a few things we use speed. When an object covers equal distances in equal amounts of time, it is moving at a constant speed. And this is what you can see on the speedometer of cars. A car has a constant speed of 96 meters per second. Most objects do not move with a constant speed. And there will be some graphing. So this is what a constant speed looks like. You can see the graph is very linear, which is just a fancy math term for straight. And it goes up in even intervals. I always round to the nearest 100th. That's just a preference I have because we're going to get weird numbers and we just don't want to guess. So always just round to the nearest 100th, which is 2 spots after the decimal. All right, so suppose a wheelchair racer finishes a 132 meter, here's our distance, race in 18 seconds. So what's their average speed? Gosh darn it, why did it format like this? Whatever. You know it's going to be distance over time. We're going to do meters over seconds. And this is going to be a very straightforward plug it into the calculator type of mentality. So 132 meters, division button, 18 seconds, and we're going to get 7.33 when we round meters for every second square, or meters for every second. Oh, good gracious. So if you want to use this method, it can also be drawn as a triangle. Sometimes it's helpful, and you just cover whichever one you're looking for. So Jack Choi travels at 1.3 meters over the course of 12 seconds. What's the average speed? Well, I know my distance and I know my time because it's given to me in the problem. I need to find my speed. So you can see how the distance is over the seconds, and then you can just divide that. I don't like this method personally. However, if it works for you, please use it. So another one. So we have Lisa visits her uncle 45 miles away if she drives an average speed. So we're given two things here. We're given our distance and we're given our speed. How long will it take Lisa to reach her uncle's house? We need to find time. So we have our miles, our distance, and our speed, miles per every hour. So plug it into the circle if you want, and then you'll also see these as triangles. We'll get to that. Plug it in there. So we have 45 miles over 55 miles for every hour. You're going to get distance divided by speed, 45 divided by 55. And it's going to take her roughly 0.82 hours. So just under an hour. All right, Carlos, another example, has a derby car that can travel 1.2 meters for every second. That's our speed. How much distance can his car cover in 12 seconds? All right, we're giving a speed and we're given time. So we need to find our distance. So we have our seconds, our time, and we have our speed, 1.2. You see how they're next to each other? In math, that means we're going to multiply. We have speed times time. We put it into our calculator or write it down on paper, whatever you're feeling, and we get 14.4 meters. All right, we don't need to watch that because we already watched that video. All right, so we'll do more practice problems with this in class. That's really the only way to get better at this kind of stuff. But we'll do more practice problems, and I'll see you guys in class.